Okay, good morning, everybody. Morning, Captain Price. Who else is here? Morning, Glazer. Morning, Tyler. And everybody else who might be watching. Hopefully everyone's doing good today. So week 5, we're actually making really good progress through the semester. And hopefully you're starting to feel more and more comfortable with HLA. Today is, well, you've already actually done some assembly language programming. You may not have noticed it a ton, but every time you use the MOV, the move instruction, which you know by now doesn't actually move anything, it just copies a value from one place to another. That's an x86 assembly instruction. So that's an example of how the HLA language kind of lets you do a mixture of assembly and higher level style of programming. Now HLA doesn't actually have a regular assignment operation like you're probably used to, the equal sign. Move is the only way to copy data. And it also does not have regular arithmetic. So if you want to do add, addition, subtraction, multiplication, division, or modulo, you have to do them using the x86 assembly instructions. So I believe, I just looked at this, but we're starting to do, we're going to add in some of the arithmetic instructions today. So I'm going to do what I normally do, is just go get us oriented. There's been no changes. I think the last time I saw you this was true, but just to be sure, all your content is now available. So you can work forward as fast or as much as you want to. You don't have to, of course, but if you like to work ahead, your entire semester's content is now available to you through the weekly modules. So if at some point you get super energetic or you feel like you need to get yourself a little bit ahead for other things that are going on in your life or in school, you can do that. And probably you'll be more confident about doing that as we proceed and you get more and more, feel more and more mastery over the HLA language. Okay, so other than that, no changes. So I'll just go to this week's module. This week I will do it through the schedule page. And also, if you notice anything weird, please let me know. Last week I used Streamlabs software and I didn't really like it, so I switched back to my open source OBS software, although I'm still on my Windows machine for everything that you're seeing me do here. Okay, so our goals for this week, primarily it's to look at how do you use the actual assembly instructions to do addition and subtraction. It won't surprise you probably to hear that these are the most straightforward assembly instructions for doing math, so that's why we do those first. So they're the least exciting and the least interesting, but they're a way to move down that path. We will add some more tricks to our HLA programming toolkit. We're going to, I think we already looked at some basic procedures, but I'm going to keep giving you more and fancier ways to set up procedures in HLA, which is simply a way to better organize your code, of course. So that's the goals for the week. The readings, so at some point I'll have us focusing a lot more on individual sections, but for now I just sort of keep having you go back and reviewing the basic syntax and also looking at how do you set up a procedure in HLA. Procedure is simply the HLA term for function or method, as you might know it. And your lab also has random numbers. For the most part, that's already been done for you, but just in case you want to see what are your options, I'll have you look in the, hopefully that link works. But I've given you this link to the standard library so that you can do that. It also, I'm hoping that some of you might start poking around the standard libraries a little bit to find other goodies that are in there. Okay, so the homework, as always, the 10 questions. which I don't review. Those are based on the reading, so I can answer questions about them, but typically I just assume that you'll do what I did. I did the reading and wrote questions as I did the reading, and hopefully you'll do the reading and answer them as you do the reading. I know, isn't that dumb? I don't really understand it. That is funny, actually. I noticed that, but hadn't registered it as being just stupid. Speed grader. I don't know, by the way, what it has to do with speed. It's just a pagination tool. All it does is make it so that you can arrow through each individual student's submissions. And I guess that was not a thing before. I don't know how you would have done it otherwise. But yeah, that's hilarious, isn't it? Okay, so we're going to come back to the lab after I work up from some basic sort of ground level examples. I'll come back to the lab and get you oriented into it. The discussion. So we're going to add an extra layer onto our integer talk. So a lot of you already know by now what it means to be an 8-bit versus a 16-bit integer, which is really just how much data, what's the range of values you can store in it. And we're going to start adding in some discussion of signed versus unsigned integers, because we're getting close to that time in the semester where we should start looking at how do negative numbers work on computers. It's an interesting system that they use to represent negative numbers. And what's last? Just reminders about what we do every week. And then the first project, some of you have done a vending machine in a class, and so it's kind of intentional on my part to bring back the vending machine in multiple places. And I don't know if other instructors do that, but I often use the vending machine project myself when I want to just do something relatively small in a new programming language, but that kind of forces me to try out some of the different basic features, like how do you do math, how do you do inputs and outputs, how do you do loops, how do you do decisions. So I like the vending machine project for creating an excuse to try out sort of the basic programming features of a language. So that's kind of what this is about as well. And the more times that you've seen it, then the more you can sort of think probably about the syntax of the language you're trying to learn, as opposed to the underlying programming challenges. You'll also notice that the underlying algorithms are basically the same, no matter what language you use. So at some point, I will try to get some talk in there about the individual project, but hopefully you're sort of on the lookout for things that you can use and incorporate into the individual project. So that's really what I would ask of you is, while we're going through lecture material like we do every Monday morning, that you're aware of what the first project is and is supposed to do, and you're looking for things that you might sort of steal from that week and use it to solve the project. I have included some screenshots down here just so if you're in doubt as to what it might look like. This is not a requirement. You can make it look like whatever you want. This is just how I made it look. And then I took some screenshots at various stages of running the program so you could see what I do when a product gets sold out, how I handle the payment procedure, and then how I handle the receipt. So that's all there on the individual project. So at some point, if I have a few spare minutes, I'll probably go look at some of the particulars, but otherwise I just encourage you to be on the lookout for tricks you can use to solve that first project. Okay, so I'm going to switch over and do some code stuff. So let me disappear Firefox and get onto my virtual machine. A few more have joined us that I can see you by name, so if I didn't say hello, hello to everybody who's here. Let me make sure that that's awfully big. That's bigger than I would like. I'm happy with that. Let me see if I can move it around a bit. How interesting. There we go. Hold on, I gotta adjust so the change in software has meant that I have to make this, there we go. All right, I could see that you couldn't see everything. Okay, 5, 4, 3, 2, 1. I'll wait for a couple seconds to pass, and then I'll go in there and do my normal setup. So I'll open the assembly programming folder. I will use the tool menu to open a terminal in here, confirming that I'm actually in the assembly folder, which makes life easier. And then I'll open up the text editor, maybe. I'm gonna make this one wider and this one scrunchier. Okay, yeah, so hopefully you're just sort of seeing, all right, let's get to the good stuff at this point in the semester. But just to be sure, I'll probably do it for another week or so, and then I'll just sort of jump in each time. Here's my terminal. Okay, so I'm going to set myself up a program. I'm going to do it as a math tutor, and the reason I'm doing it as a math tutor is because I'm going to keep adding to this. When we add the multiplication instruction, I will add this to the tutor. So you might consider doing the same if you've got plenty of work to do otherwise in the class, that's okay. But my plan is I'm going to make this math tutor and I'm going to keep adding features to it for a couple of weeks, probably for 3 weeks, as we add in new techniques. It's not going to be an exciting math tutor. It's just going to give us an excuse to try out some of the techniques that we want to practice. And then I'm just being careful here to get it in my assembly folder. Yeah, and this is odd that it does this. That if you create it from scratch this way, I always have to do, at some point it probably hits, but I always have to change it from plain text down here to HLA to get syntax highlighting. Okay, remember I don't put the documentation. That's kind of just a standard requirement that the name of the project, your name, the programmer of the project, and the date that you did it. Those are all just basic requirements, but I don't put documentation because it fills the screen. And I'd rather you have things on the screen that you can use. So, I know that what I'm going to do, what this program is going to do, is it's going to generate 2 random numbers. I'm going to create some variables. It's going to generate 2 random numbers, and then it's going to math quiz me. So what's 3 plus 5, and what's... So I'm going to use random numbers to create a little quiz, and then have the user type in what they think the answer is, and then I will compare their answer against the actual answer. Yeah, and that's how I'll do it. I'll probably keep count of like how many right and wrong they got too. So we're going to need some variables for this. The question is probably true that you don't need variables if you're super clever about using the registers, but there's kind of a trade-off. If you only ever use registers, then you're sort of getting maximum efficiency from the computer, but not necessarily maximum efficiency from you and your brain. So for me, in real life, even in assembly, I often will use variables because the small amount of RAM that I use to store a variable is well worth the trade for me to keep my data straight in my head. So I probably don't need these variables in this program, but they will make it a lot easier for me to manage my data if I do it. So I'm going to make a num1. I'm just going to use unsigned 8-bit integers here. And before I do random numbers, I'm actually going to hard code some values onto these variables. And the reason to do that if you're developing an algorithm, it's difficult to test the algorithm to see if it's correct if you're using random numbers, because you're not sure if it's the random values that are messed up. Or so before you put random numbers in the program, make sure that all of the parts work correctly with non-random numbers. It's at least what I recommend. So in HLA, if you don't assign a variable a value, by default it's 0. But you can assign a hard-coded value to a variable if you want, with this colon equals. You cannot use this anywhere else in HLA except for when you create static variables. So if you try to use this somewhere else, you're going to get an error from the HLA compiler. So the only place that you can actually use this kind of assignment looking thing is at the moment when you declare a variable. So I'm just going to code them to 5 and 3, and then I'll let that one be 0. That's going to be the user's input. Okay, so that's my variables. And again, I probably could have avoided using them, but this is going to make my life a lot easier when I develop the algorithms to just have the variables to refer to. So I'm just going to start making procedures up front because I've already begun imagining. So I'm going to probably generate more procedures than are actually necessary here. And I'm doing that in part because I want you to see a whole bunch of different ways to do procedures. Also, so that when you look at a procedure, hopefully it is pretty well focused on the task at hand. So I don't want a procedure that's doing a whole bunch of different things while I'm presenting to you. I want you to see a procedure and see that it does this one thing and it does it quite well. At least I hope it does it well. So let's, I'm going to make a show problem procedure. And if you make a procedure, with no parameters, then it does not get parentheses when you make it, when you define it. HLA programs, my main complaint about HLA is that it can be quite difficult to read longer programs because there's just a mess of words in here. Yeah, I agree, Captain Price. So Captain Price tries to keep a minimum of code in sort of the main block, and I do as well. In fact, even though procedures are hard to read, once you can find the procedure, if it's well focused and only does just the bare minimum of things that it actually needs to do, I think it does help in HLA. So yes, I would say, the question is it a good thing to sort of minimize what goes on in main? And I would argue yes, it is a good thing to keep that to a minimum. At least in terms of the engineering of this software, meaning the way the software is put together, I think that's a very good way to do it. Keep the procedures highly focused and keep the main part of the program only really there to trigger the right procedures at the right times, as it were. That's how I like to do it too. Okay. So remember the procedure definitions in HLA, they go above the main block, so just be careful about that. Also be careful about wrapping things around each other. So there's the main block, there's the procedure, there's the program opening, so you just sort of have to be careful to not sort of cross boundaries. Yeah, good point. So if you keep your procedures and your main block well organized, it's very easy to hunt down problems, right? You don't sort of have a mix of a mess in main and then some mess in your procedures. You kind of know to go to the procedure who's the guilty party, as it were. Okay, so show problem. What I'm going to do here is simply a display for my little math tutor. So it's going to be, I'm going to have parameters here. So it's going to have the first number, going to have the second number. Something feels wrong. Oh. So notice here it's semicolons to separate the arguments, or to separate the parameters. It's different when you call the function. So there's one parameter, a label, a colon, and the type, and then a semicolon to separate between that and the second parameter, label, colon, type, and then another semicolon, and then the have to be careful here to watch to see that these don't light up. And then a character for whatever operation is being represented. So there's my 3-parameter procedure. The parameters only go on the procedure line. So now I have access to these 3 as if they were local variables. And this procedure is probably maybe narrowing it down too much, but I wanted to keep focused. Its job is really just to take the number, a space, then the operator, so it might be plus or it might be minus. At some point it'll be multiply, divide, mod. So I need to put the space in there, otherwise it'll be the number mushed up against that character, right? Then another space, and then the second number, and then equals. And then I'm going to put that question mark there, possibly as a prompt, let's say. I did not put a new line because I don't know if I want a new line yet. That's part of that output. So it takes a number, takes 2 numbers and an operation character like plus, minus, asterisk, pardon me, slash for divide, and then it prints out the number and then it puts a space in there, otherwise it would be illegible. And then that operator character, and then another space, so it won't be illegible, and then the second number, and then space equals space, question mark, and then another space, because I'm guessing that I might actually end up using this as the prompt, to get the user to type in something. So there's the show problem. And I'm just going to do that real quick for both variants that I intend to implement. So one's going to be with the plus sign, and the other is going to be with the minus sign. So this program doesn't actually do anything, but one should say 5 plus 3 equals, and the other should say 5 minus 3 equals. There's no new line there, so I'm actually going to just manually output a new line between them. That is new ln for new line, so that's actually an output procedure you can call, which will put an empty line out. Okay, I got to talking for a while there. Hopefully everyone's following okay. So I'm just going to see what it does, and then put a blank line out, and then see what it does with the minuses, and hope that it compiles and all those things. Okay, so compiled. It looks yucky on the terminal because I didn't put an extra new line after that last part, so I'll go ahead and do that just so my testing outputs look nice. And then I'm going to go recompile it. First I'm going to clear the screen over there. Okay, so that's just a display, right? That's all it does. With non-random numbers, but we're going to write a procedure to do that next. So I suspect that a lot of you, you may not feel, many of you might, but not all of you will feel like you've mastered the function yet, so I think this is great practice. Take advantage of the fact that HLA lets us create functions, procedures, and sort of practice building them and getting comfortable with how to organize them and how to use parameters, that kind of stuff. Okay, so there's my show problem procedure. Probably makes sense that we have a routine here to let the user type in an answer, so I'm going to work on that one second. And you can always kind of start thinking to yourself, maybe I won't need parameters, and then add them when you discover that you do. So again, being careful not to cross over the procedures with each other. So here's show problem, all of it, and then here's get answer separately, all of it, being careful not to cross things over. Okay, so this time I'm actually going to add parameters for minimum and maximum values. So this is a tricky question. You may find it tricky to answer this question without more context, but if we're writing a math quiz, we're going to keep the math problems within a certain range, and the reason for that is because if I add, it's possible that if I take two unsigned 8-bit integers and I add them together, that they become too big for an unsigned 8-bit integer. So hopefully this is ringing a bell a little bit, but if I take an unsigned 8-bit integer that's 255 and I add 1 to it, does anyone know what that does? Or at least sort of the basic issue with that? So what's the problem with adding an 8-bit integer that's 255 with an 8-bit integer that's 1? Good one, Captain Price. Overflow. So we call that overflow. The biggest value that an 8-bit integer can hold is 255. So if you take 255 and you try to add numbers to it, you create what's called overflow. Which means that the results of your addition are incorrect. Yeah, it wraps back around, Captain Price. So what you'll find if you practice with it is that it wraps back around on itself starting at 0. But effectively, if you add two unsigned 8-bit integers together, and you get, what's the word I'm looking for? Oh, and you get something that's bigger than 255, you basically get an invalid result. So working at the assembly level, you have to be aware of these things. That if you're adding two unsigned 8-bit integers together, you might get a result that is in error because it's actually too big for an unsigned 8-bit integer. Yeah, and Captain Price kind of alludes to the other problem. If you subtract an unsigned 8-bit integer from another, then you can get the same problem in reverse. That you can end up like 3 minus 5 is -2, but that can't exist with unsigned integers. So you end up getting a bad result. So anyway, these are things to keep in mind as you implement a math tutor, is that at the assembly level, there's all kinds of chances that you might get overflows. Now we're going to worry about that in a second, but the reason why this minimum and maximum parameters are here is so that we can try to limit overflow. But we might do it, so we'll just deal with it when it happens. But one thing we could do is we could just say, well, let's keep the math, say, between 1 and 100 or something, and we still have the negative numbers problem, but we'll deal with that. Anyway, the reason why you might consider limiting their inputs for a math quiz is because you might be trying to make sure that the math quiz doesn't actually compute bad data. Okay, so the way this is going to work, we're just going to embed the input sequence inside of a loop where we'll check their inputs against the desired minimum and maximum. So first thing I'll do is I will try to get an unsigned 8-bit integer and then get in the habit of flushing the input after all the gets. Some of you had this problem on the last lab, so get in the habit every time you have a get, do a flush right after it, and you will eliminate a lot of errors. So I get a U8, I do a flush input, and then I simply break if my input was a valid one. So my input's sitting in AL. If it's greater than or equal to the minimum value and it's less than or equal to the maximum value, then we got a good value. Yeah, Captain, and Captain Price points out that they had that problem. I still have that problem. I'll forget to do a flush, and then like my program will like race past where I was expecting to have to type something like, I didn't flush the input. So if you have an input issue, it's probably because you didn't do a flush input. Okay, so I'm going to get a U8 that goes in AL, we know. Then I do a flush input because that eliminates a lot of errors at the keyboard. And then I have a breakout of my forever loop if AL is in the desired range. Now, if you're clever, you will realize that this line where my cursor is, that line will only execute if the break if didn't happen. So if the break if doesn't happen, I know something. I know. Let me stretch this out a little bit. So if the break if doesn't happen and I get to the next line below it, that means the break if didn't happen, which means that they had a bad input that didn't pass the test. So I can actually put a nastygram on the screen asking them to type in a new input. I might actually turn that one into, instead of a new line, I might actually turn that one into a new prompt. Yeah, the flush input errors, sometimes you'll get away with it and sometimes you won't, and it can be difficult to figure out when you're getting away with not doing a flush and when you got caught because you didn't. So yeah, eventually you'll just sort of get in the habit of putting the flushes always there because they can be difficult to track down. Okay, so here's a procedure. Now someone asked about this on the lab, I think last week. We haven't added it in yet. If they type hello here, the program's going to crash. We are going to handle that soon. But for now, we're just going to make sure that if they type a number, that it falls within the desired range. Okay, so get an answer. So I can show a problem and then get an answer. I'm just going to say, let's say between 1 and 100, and I'll keep the problems so that they land between 1 and 100. And then the thing to remember here is this get answer is actually sort of using get U8 to do the work. So when get answer comes back, AL has their input in it, so I immediately want to move it into my usernum variable. And I want to do the same thing. Let me push this down a little bit. I want to do the same thing for the second problem also. Okay, so I show the problem, then I get an answer, and I'm going to make sure that the math quiz does not produce results that are over 100. And then their answer will be in AL, so I will use the move instruction to copy that into the usernum variable. And then I'll do the same thing for the second problem. Now I'm only doing this, I'm actually mostly going to run this so I can test to see if I put 0 or I put 101, that it would break. Negative numbers, it will crash because it's only expecting unsigned 8-bit integers. So keep that in mind. This thing is not crash proof. It's only range proof. Save, yeah. Get, oh, standard in dot get U8. So if you're following along, check that one on line 21 for me. Is standard in get U8. Standard in, because it's input. No, it was just the standard in part, Captain Price. I had standard out there because I wasn't paying attention. So get U8 is correct. Well, I say that. I saved it. I changed that to standard in get U8, and I think that's, yeah. So it was just that. Okay, so there's my output, and then my get answer is actually just sitting there waiting. So I'm going to put a 0 in. I should get a nastygram. So I got a nastygram. I'm going to put 101 in there. Should get a nastygram. So anything in between should be okay. And then it goes to the second one. There's my extra little line break, my standard out dot new line. And then here I'll just put 1. That should be okay. And there's my extra new line at the end, just kind of making it look nice. Yep, it's a good thing. Generally speaking, by the way, one of the reasons we like compiled languages is because you get the errors at compile time. In other words, you get the errors before your customers or your clients get the errors. So it's actually desirable, even though you get tired of fighting compiler battles. But that way your clients or your customers will never know our dirty little secret that we spend a lot of time making mistakes. And we hope the compiler catches us and helps us fix them. Okay, so there's my get answer part. What else do we need to do? We need to actually do the computations, right? So one thing is I have a weird, well, let's just let it happen, shall we? Let's just let it happen. We need to get some numbers. No, let's do the calculation. Let's do random numbers last. So let's do the calculation. Do we want to do, let's make these separate. Okay, so now we'll do the addition instruction. And it's pretty straightforward. The only thing to know, and I'll put the signature up here, is add source destination. Which you've seen this because I did an add 1 to something. But remember, it kind of works left to right. So by doing add source destination, it's the same thing as saying the destination equals the destination plus the source. So it might even be easier to conceive of that as being destination plus equals source. And I think it was actually, I think Captain Price actually pointed this out. Close, Captain Price. There's a catch when we're working at the assembly level. So some of you might remember this add and the math generally easier if you think of it as the plus equals. Just remember that the old destination value gets updated by having its old value. Its new value is its old value plus whatever the source is. So what you're going to want to do is what Captain Price says, which is num1 and num2. But we're going to get a compiler error, so let's look at the compiler error. Or there it is. Okay, line 35. So the compiler error is very vague. It doesn't actually tell you squat about what you need to know here. Let me rerun it a little bit. So it's complaining about line 35. But it doesn't actually tell you anything other than it was expecting a parenthesis. Well, that doesn't make any dang sense. That's the right idea, Tyler. So the problem here is it's two variables. It's memory to memory. Good one, Captain Price. So just like with comparisons, you can't do memory to memory. With math, you also need to do some offloading. So I usually offload the second operand into a register. And actually, in this case, that's what you want, because you don't actually want to alter the original number. What you want to do actually is just produce a separate result. So in the book, and unfortunately I couldn't think of a better way to say this, it just seems like old language, but what he will tell you in the book is that when you're doing assembly style arithmetic, you need a middleman. So AL is going to be the middleman here. It's going to serve as the place where we actually perform the calculation and have the result deposited. So we need add AL. So if I copied the value of num2 into AL, and then I say AL plus equals num1, well now AL is the sum of num1 and num2. So I would leave it just like this, because you don't want to alter the original num2. And you wouldn't be able to do that anyway because you're inside of a procedure. So what I recommend that you do is just let the procedure tail off right there. So what happens is you call the procedure and you get a result in AL. And that's it. That's basically it. So AL is a middleman. So now, when I come down here, I can do addition on num1 and num2, not risking any possibility that I've changed those things, and then what I get back is AL. So now I'm going to show you something that may make you slightly uncomfortable, but it's cool to have. So hopefully you're not getting overwhelmed by procedures. How much time do I have here? All right, I have a few more minutes. I may not get subtraction. I'll try to get subtraction in. Oh, really? Hopefully, that's not. Oh, that's bad. On my end, I don't see any frame drops or anything that should be of any consequence, so I don't know if you're all having that experience or not. But one person's having bad resolution out there. Okay, it's not too bad. Hopefully, maybe a refresh will fix it, Captain Price. Yeah. Okay. So I'm loading up lots and lots of procedures because I want you to see a bunch of different ones. So I guess let's go ahead and do the subtraction while we're at it, and then we'll compare their number with the actual result. So at this point, you know what's coming. So it works exactly the same. We're going to load up the middleman, and then we'll say AL, which is the value of num2. AL equals basically AL minus num1. So you have to be careful here, because with addition it doesn't really matter who comes first, but what this means is num2 minus num1, and that's not what we want. So we need to be careful when we're loading up the middleman that we get the arguments in the proper order so that the math works right. So if we want num1 minus num2, then num1 goes into the middleman, and then num2 is pushed into the subtraction. instruction. Hopefully that makes sense to everybody. You sort of have to, and the best way to figure this out, of course, is to put it in a program and compile it and run it and see if you get what you wanted and pay attention to the results. But you do have to be mindful when you start using these slightly more complex instructions that the order of things matters. So num1 goes into the middleman because I want num1 minus. And if I do sub in this way, this is AL equals AL minus num2, or AL equals num1 minus num2, which is the order that I wanted. So anyway, be careful about that. And then down here we would do subtraction, num1, num2. So add and sub are not complicated, but hopefully you notice, like right off the bat, you have to really start paying attention so that you don't get things in the wrong order. So pop my neck. So anyway, that's a potential gotcha, but you'd immediately notice because the results would be wrong. Now I'm going to do some trickery on the numbers to make sure that I get the kinds of results that I want. Okay, so that's it, do subtraction. Now we need a procedure that compares their number with the actual computed value, and if they're the same, then they got it right, otherwise they got it wrong. So the hopefully you're able to track this somewhat. Again, just sort of being very careful that the procedures stay separate from each other. So now I'm going to get a computed number and a user number, and if they're the same, then I'll say hooray, and if they're not, then I'll say not hooray. So these are basically like two variables, and you can't do memory to memory. So I'll refer back to what Captain Price said earlier, which is you got to offload one of these into a middleman for the sake of comparison. So it doesn't really matter in this case. I'll take the computed num and put it into AL. This is going to seem weird in a second when you see how we get here, but once I'm in the context of the procedure, I need to put that computed num parameter into a register so that I can then do this. So if the computed number is the same as the user number, then you got it right. Else, no, the answer was, I think I'll put me a dot at the end of that one. And being careful to put an end diff in there. We are making use of AL pretty heavily, but you'll find, the question is, are we kind of abusing AL here? You're going to find that you end up using, for whatever reason, it's kind of tradition, use A first and foremost for a lot of this kind of stuff, so you do kind of make heavy use of it. And you also use C a lot, as it turns out, because C is the traditional counting register. And no doubt that's because it has C in it that people started to use it as a counter. B is used for base addresses of stuff, as it turns out. But that's just tradition. So yeah, we do use A a lot, but that tends to be what we use as our go-to middleman for all kinds of stuff. It's a good question, though. Okay, so there's the, you got it right or you didn't get it right. Now when we call this, what does that look like? So down here we'll do addition. And do addition deposits the result in AL. So I will compare results passing AL as the computed number. Now this is AL, which is sort of just 8 bits of whatever. And then in my compare results, notice it's an UNS 8. As long as the sizes match in almost every case, HLA is cool with it. So as long as this thing is 8 bits in size, HLA is going to let you do it. It's going to assume and interpret it as an unsigned 8-bit integer when it sees those bits. But how they get there, HLA doesn't care about. If it's 8 bits, it's 8 bits. The other one is username. And then I'll do the same thing down here. Compare results, AL, and username. Yeah, AL is just gonna, it takes a pretty good licking in assembly language programming. It just gets used a lot. Okay, so we're gonna get a wrong answer here, by the way. I already know this because of my setup. Okay, so I'm gonna go ahead and say this. I'm gonna go ahead and answer them both correctly. Oh no, these are going to work out. These are going to work out. It's okay. So there's 2 correct ones. Let's, by the way, you can combine. You can sort of clear the screen and then run your program all in one command. Handy to know. It saves you a little bit of time. So I'm going to answer wrong in both cases, just to see if that works. Okay. So I'm pretty happy with the way that tutor works. Where am I on time? Okay, I'm going to have enough time, I think. So the big stars, really the new stuff. Most of this stuff isn't new other than the extra procedures. It's the add and subtract instructions. Yeah, 256 will just absolutely crash it. So if I type 256, it'll crash the program because it's not a valid unsigned date. So we will be adding code to prevent that crash and actually deal with it sooner than later. Okay, that's it. So there's one trick here. As long as the first number is bigger than the second number, this is always going to be okay. But if I switch these, if I switch so that num2 is actually bigger, then watch what happens. So that's still 8. If I try to actually type the correct answer, the program crashes because you can't type in negative numbers. And if I sort of then say, well, maybe I say 2 and it won't allow me to say negative, well, that's wrong. And the answer is not 254, but what happened is it subtracted itself down below 0 and came back around, which is kind of crazy, isn't it? You can. So the question is, could I catch the fact that this is becoming negative and do something about it? You can. So you can actually, after the subtraction, you could catch that. I think you're going to have a carry bit. Let's see. I think we're going to have a carry bit. So this is actually looking at the status register on the processor. Let's see if we can catch it. So this little piece of code in subtraction, I'm adding a little piece of code because you can, as Captain Price asked, can we detect this and do something about it? And the answer is yes, you can. So in theory, I can detect if I got a wraparound. It's either going to be an @C or an @O. And I don't remember off the top of my head which it is, so let's find out. Okay, so it was an @C. So you notice my program detected the error, and in that case I could have done something about it. So that's kind of cool, isn't it? You may not remember, but we had a question about E-flags, E-F-L-A-G-S. In fact, I'll put a note here. I'm checking the E-flags register for this error condition. So you can actually detect this. I believe it'll be at O for the add, which you can try. But anyway, just so you know, there is a way to detect that. Now there's a better way to handle that, which is to simply prevent this from happening. Well, that's not a better way to do it. It's a better way to do it if your toolkit is limited, right? If your toolkit is limited, just try to set things up so that the errors won't happen. There could still be an error here, by the way. Let's see. Okay, there wasn't, so that's all good. Okay, I need to stop and look at the lab for a few minutes. I'm going to keep my tutor program, so you're going to see more of this. And I know this doesn't help you for me to scroll it. If you think there's something in here that you would like to have access to, I can like post the code up in Piazza in its current state, so just let me know in chat. What does -A check? I don't know. What is that flag? So the -A, I don't know. We'd have to look in the documentation to see what the A is. I don't know off the top of my head. @C is carry. So this means that the binary arithmetic in the circuit of the processor had a carry bit as it was subtracting down off the end and back around. When you do add, this is probably @O for overflow. You'll get an overflow bit. And sometimes you have to experiment a little bit to see which of these bits is actually the one that's detecting the problem. Okay, so let me know in chat if you want me to, I can put this on Piazza if anyone wants to have access to the source in its present state. That's not a problem, just let me know in chat. Okay, I need to load up Lab 5 and just sort of do a walkthrough to make sure that you know what to do in there. So let me do a new file. Save this in my ASM as lab5.hla. Yeah, I think I will. So I will post the math tutor code, and I'll probably like version it inside of Piazza, so you'll see a new note that says math tutor code or something like that, and I'll flag it with this week on it. Will I do that? I'll probably put it in miscellaneous, and then I'll version it so as I add to it, I can put a new version on the same post. Okay, so Lab 5 for a couple minutes just to get you started. Let me switch back. Switch back and go grab the lab code. Hope I'm in the right class, yeah. And like I've been saying, I go to this raw button here in GitHub. You're seeing that, yeah. So I click on this raw button because it makes the copy and paste go just a little bit faster. So Control A, Control C, and then back to my virtual machine. Control V, S. Okay, and that time it just took as an HLA file, so I'm pleased with it. Okay, so there are, how many items does the assignment say? There are 9 numbered items in here. So you need to find the 9 things and fill in the gaps. So there's a bunch of procedures. They're all commented to tell you what it is that they're designed to do. So this first one is just print a greeting, like, welcome to my Lab 5. There's a procedure here, so it tells you what it does, But your main job is just to find these numbered items and make sure that you implement them. So this one wants you to put a break-if statement in here. Inclusive means that if the minimum number is, so inclusive means greater than or equal to, and less than or equal to. That's what inclusive means, including those numbers. If it said exclusive, then you would say AL greater than min and AL less than max. And some libraries are written that way. But for us, inclusive means that your break-if should say AL greater than or equal to min and less than or equal to max, which is how you make it inclusive. That's number 2. Number 3, I'll give you a starter on this. It's kind of already telling you the logic that it wants, but the idea is that I did something wrong. Something bad just happened. I full screened it and I don't know how to get out of it. Oh, it doesn't matter, does it? I just got to make sure that you can still see it like that. Okay, you can. Where was I? Number 3. So use the parameter, which is number, to do this decision tree. So, I mean, all I really mean is take number and say if it's 1, then put probably with a new line if I had to guess. You can experiment and see what you like better, else if. So that's all that one means. Take the number that's the parameter and write a decision tree that spits out cherries on 1, money on 2, star on 3. That's number 3. Spin one wheel is already completed. There's no numbers in here, so I don't need to touch it. But there is some stuff you might look at. I just thought this was easier to explain by implementing it for you and then having you sort of consider what it's doing. So this is a distribution, a probability distribution. There's a 60% chance of something. There is it's actually 59%, but whatever. 30 more on top of that, so 30%, and then a final 10%. So that's already done. It's using random numbers to distribute into a certain probability of outcomes. Spin all the wheels. Does have one numbered item. So this one's going to be a pain in your rear. Because you have to do this logic tree, right? When they're if they're all ones, so if wheel 1 equals 1 and wheel 2 equals 1 and wheel 3 equals 1, else if wheel 1 equals 2 and wheel 2 equals 2 and wheel 3 equals 2, else, this is the else part, right? So they're either all 1s, else if they're all 2s, else if they're all 3s, else they don't match, nothing comes back. Although once I've clicked on someone, I don't know how to make them go away. How do I make this go away? Oh, like that. Okay. So anyway, that's an if, else statement. There's the conditions are in the documentation. Number 5. So you already have a play again procedure from Lab 4, so I would just go grab it and put it in there. It does explain to you what it's supposed to do, but there I thought just sort of getting comfortable with reading code and realizing that you can sort of take stuff from one lab and reuse it might be helpful. So that one you already have from Lab 4, and that's true. If you did Lab 4, then you're going to have that code. If you didn't do Lab 4, then you may have to do Lab 4, or at least that part, to get that code. Number 6. This is a subtract, and I know I'm taking all the fun away, but I'm worried that people won't. So subtract the user's wager from the bankroll. So what I need is bankroll equals bankroll minus wager here. So you need a middleman, which is going to be AX. And the reason why AX is the middleman is because bankroll is a 16-bit integer. And then you're often going to see this because you have to use a middleman for the math. So you load up a middleman, you do the subtraction, and then you copy the new bankroll value back into bankroll. So you overwrite bankroll with the newly computed and reduced bankroll value. Okay, so that's a hint about that. I really just left the sub part for you, but to get you thinking about how the middlemen work, generally you put some value in a middleman, you do some math, and then if needed, you copy or move the result back into the original variable where it was supposed to be tracked. All right, so here's number 7. So this is another one, except for it's add, right? So you have to have a middleman for bankroll. Then you add the wager to the middleman, and then you move the middleman back to the original bankroll variable so that you get the update tracked. Here's another one, same thing. Oh, well, let me help you with this one, because it may not be entirely obvious. So you know this part, middleman. So we don't have multiplication yet, so you sort of have to think, well, how can I double their winnings if I don't have multiplication? Well, I can just add twice. That's double the wager. And then store it back into the long-term variable. So that's doubling the winnings, simply by doubling the number of additions I do of the wager onto their bankroll. Hopefully that makes sense. That one's done now, like that. It does say add AX to the bankroll 2 times. So this is what we would do if we didn't have multiplication instructions, which we don't yet. You will, though, pretty soon. You just do multiple adds. Number 8, triple the winnings. Number 9, a break if, just like you did on Lab 4 if you did Lab 4. And then we've probably been using them, but I'm using the HLA clear screen procedure, which I love that it's built into the standard libraries. Why doesn't C++ do that? Who knows? And then when the program ends, it will tell you how much you finished. So it's a little slot machine program, kind of, a little crude slot machine program. I don't care if you go up to spin the wheel and change the odds just to see what happens. I'm sure that these odds are terrible, by the way. Okay, that's it. So I'll sit here for a couple of seconds. I will wish you all a good week ahead. Hopefully this arms you with what you need to be successful. Also, again, start being on the lookout for what you can use on Project 1, because there's a lot of stuff going on in here that you can use on Project 1. So have a look at that sooner than later so that you can begin it with confidence and end it successfully and with confidence. Thank you, Captain Price. I appreciate it. Otherwise, I think I'm done. So have a great week. I'll see you on Monday next week. That will be the 6th week of the semester, so we're doing quite good. Hopefully you're feeling good about it and you're feeling good about this class, because as far as I can tell, everyone's doing great. Thanks for the Piazza activity. I appreciate it. And I will post this. I won't forget. I will post this right now into Piazza as a new note under miscellaneous with the math tutor code as far as we got through today. Thank you, Tyler. Appreciate it. Okay, signing off.